This conference will now be recorded.
Good morning, all of you. So today I'm going to talk about today I'm going to talk about anterior pituitary gland. As all of you know that pituitary gland is known as the master gland of endocrinology. It plays a vital role in our body. So you know that this pituitary gland got two lobes, anterior, and posterior. Anterior pituitary and posterior pituitary. So this is the weight about one gram, and it lies below the hypothalamus. Okay. So now this hypothalamus releases the tropic hormones. So these tropic hormones are known as hypothalamic tropic hormones. So this hypothalamic tropic hormones passes by hypothalamic pituitary portal vein, and it stimulates the anterior pituitary gland. So the anterior pituitary gland secretes growth hormone, prolactin, thyroid stimulating hormone, follicular stimulating hormone, luteinizing hormone, ethnocorticotropic hormones. So posterior pituitary gland secretes oxytocin and vasopressin. I think yesterday I have seen the posterior pituitary gland. So today I am exclusively talking about the role of anterior pituitary gland and its functions in human body. So I am repeating once again: the anterior pituitary hormone secretes growth hormone, prolactin, thyroid stimulating hormones, follicular stimulating hormone, luteinizing hormone, ethnocorticotropic hormones. See, as aware that this is known as another name for the anterior pituitary gland is adenohypophysis, and the posterior pituitary is neurohypophysis. See now, these anterior pituitary glands are stimulated, and they're stimulated by the hypothalamic tropic hormones. These hypothalamic tropic hormones are secreted from the hypothalamus. So, say, take for example, prolactin releasing hormone and prolactin inhibitory hormone. So, this prolactin releasing hormone stimulates the anterior pituitary gland to release the prolactin, and prolactin inhibitory hormone, and it inhibits the release of the prolactin. Like this, thyrotropic releasing hormone stimulates the thyroid stimulating hormone, corticotropic releasing hormone stimulates the ethnocorticotropic hormone, growth hormone releasing hormone stimulates the growth hormone, and growth hormone inhibitory hormone, that is known as the somatostatin. Another name for the growth hormone inhibitory hormone is the somatostatin. And next one is the growth hormone releasing hormone. It stimulates the luteinizing hormone, follicular stimulating hormone. So like this anterior pituitary hormones are works under the control of the hypothalamic tropic hormones. So this hypothalamic tropic hormone facilitates the release of the prolactin, thyroid stimulating hormone, ethnocorticotropic hormone, growth hormone, luteinizing hormone, and follicular stimulating hormones from the anterior pituitary. And at the same time, so these hormones, prolactin, take for example growth hormone. So the growth hormone, see, actually the signals for the release of this growth hormone comes from hypothalamus. So hypothalamus releases the tropic hormones. These tropic hormones stimulates the anterior pituitary gland, and it releases the growth hormone from the anterior pituitary. So this growth hormone acts on the tissue growth. Next, thyroid stimulating hormone. So thyroid stimulating hormone acts on thyroid gland to facilitate the release of the thyroid hormones, and ethnocorticotropic hormones acts on the adrenal gland to release the cortical hormones, and follicular stimulating hormone, luteinizing hormone acts on the testis and ovary, and it helps in the release of the testosterone, sperm, and from ovary, ova, estrogen, progesterone, and prolactin, especially acts on the breast glandular tissue. So like this, these are anterior pituitary hormone. So as you are aware that the antidiuretic hormone, which is released from the posterior pituitary, acts on the kidney and water absorption, and next oxytocin, which is released from the posterior pituitary gland, acts on the breast, and it helps during lactation period, and it helps in the uterine contractions. So oxytocin. So like this anterior pituitary, posterior pituitary, or works on the control of the hypothalamus. So as all of you that we are going to see one by one the role of these hormones in our body. So now let's just recollect now. So what are the hormones released from the anterior pituitary gland? So anterior pituitary gland releases the growth hormone, prolactin, thyroid stimulating hormone, follicular stimulating hormone, luteinizing hormone, adrenocorticotropic hormone. So these are the 6 hormones which are released from the anterior pituitary gland. So this is one mnemonic. How to remember this anterior pituitary hormone. So this is the mnemonic for anterior pituitary gland. Flat peg. Flat F stands for follicular stimulating hormone. L stands for luteinizing hormone. A stands for adrenocorticotropic hormone. T stands for thyroid stimulating hormone. P stands for prolactin. E stands for endorphins. G stands for growth hormone. So flat peg. So this is the numeric word for to remember anterior pituitary hormone. F stands for follicular stimulating hormone. L stands for luteinizing hormone. A stands for adrenocorticotropic hormone. T stands for thyroid stimulating hormone. P stands for prolactin. E stands for endorphins. G stands for growth hormone. So now is whatever the hormones are released from the anterior pituitary gland is divided into 3 classes. So growth hormone prolactin, second one glycoprotein hormones, third one pro-opiomelanocortin peptide family. So growth hormone prolactin, second one glycoprotein hormone, third one pro-opiomelanocortin peptide family. Let us see the first one, growth hormone. Growth hormone, the name itself indicates it helps in the growth. Now let us see the biochemical role of growth hormone. So as all of you are aware that so hypothalamus, so the pituitary gland lies below the hypothalamus. So hypothalamus releases the growth hormone releasing hormone or somatostatins. So this growth hormone releasing hormone facilitates release of the pituitary gland, and the pituitary gland releases the growth hormone. See, this growth hormone acts on the muscle, and let us see the role of growth hormone. So one it acts on the muscle, another it acts on the bone, and next it acts on the liver and adipose tissue. Okay, so now let's see in detail what's the role of these hormones on different organs. So the growth hormone releasing hormone releases from the tropic hormone releases from the hypothalamus. It acts on the pituitary gland and it helps in release of the growth hormone. So this growth hormone shows its effect on bone and muscle, adipose tissue, liver. So now one saying is there for growth hormone. So proper sleep is essential for the release of the growth hormone. If you won't sleep, the growth hormone won't release. So that's why sleep is the best indicator for the release of the growth hormone releasing hormone. So say growth hormone. So another name for this growth hormone is the somatotropic hormone or somatotropin. So as all of you know that it's a proteinaceous hormone. It is made up of with 129 amino acid and its molecular weight is 22,000. And this growth hormone helps in the growth of the almost all tissues of our body. So it promotes increasing size of the cell and increasing mitosis and differentiates the cell to cell. Simply, it specifically differentiates the cell to cell and such as bone growth cell and early muscle cells, and it helps it promotes increase in size of the cells. I'm repeating once again, this growth hormone increase the size of the cell and increase the mitosis. Okay, with the development of the greater number of cells and specific differentiation of cells such as bone growth cells and early muscle, and this direct effect. So this growth hormone binds directly to the target cells. So where is the target cells are located? Target cells are located in bones and muscle. and stimulates the growth. So it's nothing but hypertrophy. Hypertrophy is nothing but it increases the size and volume of the cell. And at the age advances, so there is increase in the example. As the age advances, there is increase in the thickness of the bone, and it stimulates the cell reproduction and increase the rate of mitosis. Okay, so another term is the hypertrophy is nothing but increase in size. Hyperplasia means increase in number of the cells. As all of you know that it increases the proliferation rate. So you know that there is a term called as the the cells apoptosis. So there is a continuous production of the cells, and at the same time the cells undergoes death and the replacements of the new old cell with new place with the new cell. This is a continuous phenomenon. So hyperplasia means increase the number of cells and proliferation rate, and at the same time it increases the bone length. So that's why as the age advances, there is a increase in the thickness of the bone and increase the length of the bone. This is possible only due to the growth hormone, and it stimulates the cell metabolism. As all of you know that as the age advances, there is increase in muscle mass. So for building of the muscle, you require the proteins are essential. So then that's why this growth hormone stimulates the increases the protein biosynthesis, and at the same time, this growth hormone increases the breakdown of the fat. That's why the role of what's the role of growth hormone on fat metabolism and adipose tissue. As all of you know that this fat is located in the form of triglycerol. Sorry, the fat is located in the adipose tissue, and this growth hormone increase the fat breakdown for the energy, and at the same time this growth hormone increase the glycogen breakdown. So that's what's the role of this growth hormone on liver means. One is as all of you know that the glycogen which is stored in the liver, which contributes the blood sugar levels. So as all of you know that the glycogen is stored in the muscle as well as the liver, but liver glycogen only contributes the blood sugar level. So so this growth hormone increase the glycogen breakdown, so that there is an increase in the blood sugar level. Okay, there is an increase in the blood glucose level to fuel the cell growth, because you know that there are different factors which are essential for the cell growth. One among the one is the blood sugar level. So this growth hormone uh, it helps in the breakdown of the glycogen, and it contributes the elevation of the blood sugar level. Then coming to the growth hormone. See, yes, often the name itself indicates causing the growth. Okay, and it increases the rate of protein biosynthesis in most of the cells of the body, and it helps in the mobilization of the fatty acids from adipose tissue. Okay, and it increases the free fatty acids in the blood and increase the use of fatty acids for the energy. So the one is the release of the fatty acids, and release of the free fatty acids in the blood, and increase the free fatty acids for the energy purpose and breakdown of the oxidation of the fatty acids. So that is the role played by the growth hormone. So on protein metabolism, so it increases the protein synthesis. Next on fat metabolism, and it facilitates the release of fatty acid from the adipose tissue, because you know that the adipose tissue is the storage type for triglycerides. So these triglycerides and the fatty acid are released from the adipose tissue, and these fatty acids are utilized for release of the energy. And that's why decreased rate of glucose filtration throughout the body. Thus, in effect, growth hormone enhances the body protein use of the fat stores and conserves the carbohydrates. Mainly, its role is the conserve the carbohydrates and increase the utilization of the uh, fat from the body. And another role is because these are all repeated points, and increase the protein biosynthesis in most of the cells of the body, increase the mobilization of fatty acid from the adipose tissue, this repeated point, decrease rate of glucose utilization throughout the body. So overall, the growth hormone enhances the body protein, and it uses up the fat stores and conserves the carbohydrates. So what's the role of growth hormone on metabolism? On fat metabolism, one is it facilitates release of the fatty acids from the adipose tissue. And next one is the enhances the protein body proteins. Third one is the conserves the carbohydrate. That is the overall effect of the growth hormone. Then we'll see in between little detail about the role of growth hormone on protein metabolism. And this growth hormone, because we are taking protein as such in the diet, this protein undergoes the digestion, absorption, and the amino acid deliveries. And this growth hormone enhances the transport of the most of the amino acids through the cell membrane and interior of the cells. See, for the biosynthesis of the any protein, you need to have all 20 amino acids. So, if suppose one amino acid is missing, that leads to the incomplete protein biosynthesis. So, incomplete, as all of you aware that the incomplete proteins are functionally inactive. So, that's why for the biosynthesis of the proteins, the amino acid has to be transported into the interior of the cell. That is play a role of the growth hormone. So directly enhances the directly enhances the entry of these amino acids into the entry of the amino acid into the cell, because you know that the amino acid, the protein biosynthesis takes place in the ribosomes. So that's why one is the it enhances the transport. Second one is the increased amino acid concentration in the cells, and it responsible. So you need to, that's what I said, for biosynthesis of any protein, you need to have all 20 amino acids in proper concentration. If suppose one amino acid missing, that leads to the improper or incomplete protein biosynthesis. Incomplete proteins are functionally inactive. And you know that what is the central dogma of molecular biology? Central dogma of molecular biology includes replication, transcription, and translation. So here growth hormone stimulates the transcription of DNA. See, you know that for biosynthesis of any protein, the information is present in the form of gene in the DNA. So first the expression of the gene takes place. So how it is expressed? Via the transcription. Via the transcription, the biosynthesis of the RNA and biosynthesis of the mRNA, rRNA, tRNA, and from the transcription, the via translation process, the biosynthesis of protein occurs. So this growth hormone stimulates the transcription of DNA in the nucleus. So it increases the concentration of increases the quantities of RNAs, different RNAs, and these RNAs are helps in the biosynthesis of the protein in the greater amount by the ribosomes in cytoplasm. And at the same time, growth hormone decreases in the breakdown of cell protein. It also mobilizes a large quantity of free fatty acids from the adipose tissue. This is all I told you. The growth hormone helps in the release of the free fatty acid from the adipose tissue, and they are used to supply most of the energy for the body cells, thus acting as a protein sparer. So this is the role of growth hormone on the protein metabolism. And let's see what's the role of growth hormone on fat metabolism. So as already told you that the growth hormone facilitates release of the fatty acid from the adipose tissue and increase the concentration of the fatty acid in the body fluids. And the growth hormone enhances the conversion of the fatty acid to acetyl-CoA. So the acetyl-CoA, because you know that again we have to go back. So how this acetyl-CoAs are released from the fatty acid, and this acetyl-CoAs are enters into the via the mitochondrial membrane, enters into the mitochondria with alpha carnitine, and later the breakdown of this acetyl-CoA, and the release of the acetyl-CoA takes place via the beta oxidation, and this acetyl-CoAs are enters into the TCA cycle. From TCA cycle, it enters into the electron transport chain and generation of the ATP synthesis. And this growth hormone enhances the conversion of the fatty acid to the acetyl-CoA. So acetyl-CoA is the key molecule in our body. See, for this conversion of the fatty acid to acetyl-CoA, this growth hormone is increases. Growth hormone is essential, and increase in the lean body mass. Okay, and large quantities of acetoacetic acid are formed by the liver and released into the body fluid, thus causing the ketoacidosis. And the excessive secretion is always harmful. And growth hormone. So general function is the hypertrophy. As I already said, it increases the cell size, okay, size of the cells, and increase the bone thickness, and it stimulates the cell reproduction, increase the rate of mitosis, and hyperplasia increase the number of cells and proliferation rate, and helps in the increase in the body bone length. Okay, and growth hormone, the role of growth hormone, the role of bone. So the effect of growth hormone on skeletal growth mediated by the family of the polypeptide called somatomedian. Growth hormone increases the number of cells in muscle and bones, and thyroid hormone, insulin. They are also necessary for the normal osteogenesis. So insulin increases cytoplasmic growth. Thyroid hormone required for full effect of growth hormone on DNA replication. And at the same time, you'll come to know that growth hormone itself is not itself it won't work out. So it required some additional enzymes like thyroid hormone and insulin. Both are required, and the deficiency, if there is any deficiency secretion of the growth hormone, leads to the dwarfism. So see this one, dwarfism. So the cause for this is tumor. So any tumor in the kind of tumor in the anterior pituitary gland, it leads to the hyperpituitarism. So the tumor causing hyperpituitarism decrease the hormonal output. Hormonal output. So it's a stunted growth occurs, so that's the dwarfism. Then coming to the increased release of the growth hormone causes the gigantism. Gigantism. So the oversecretion of this growth hormone causes the results in gigantism. So usually these gigantic persons usually have poor health. So signs and symptoms of gigantic. You can expect this question for 3 mark short notes. So so extremely tall stature, large hands and feet, and so prominent forehead and jaw, and persistent headaches. Extremely tall stature. See this person, observe this person. Extremely tall stature and legs, large hands and feet. Okay. Next to prominent forehead and jaw, and next to persistent headache, and acromegaly. So what's the difference between gigantism and acromegaly? So usually this acromegaly occurs between 20 to 40 age, whereas gigantism occurs before 20 years. Before the 20 years. So now this acromegaly, see what are signs and symptoms of the acromegaly. So here there is excessive production of the pituitary hormone. So the pituitary adenoma. So the local effect of pituitary tumor deficiency syndromes are visual field defects due to the compression of the optic chiasma by pituitary tumor, and gynecomastia. Gynecomastia means the increased breast size in males, and this is due to the increased prolactin secretion in hypertrophic mammotropes, and excessive body hair, sexual dysfunction, enlarged wide, spade-like hands and feet, and arthrosis, and peripheral neuropathy, cardiomegaly, atherosclerosis, and hypertension. Okay, bowing of spine. This is called kyphosis, and osteoarthritis, and arthrosis. So these are mainly almost all, see, because of this overproduction of this pituitary gland, pituitary hormone, that is especially growth hormone. So it leads to the impact falls on the almost all tissues in our body. First, visual field is affected. Visual field is defect due to the compression of the optic chiasma by pituitary tumor. Next, gynecomastia. Next one is enlarged wide spade-like hands and feet, and bones, especially arthrosis, and nerve system, the peripheral neuropathy. So these are all mainly because of the increased production of the growth hormone, and cardiomegaly, and atherosclerosis, and hypertension, and next to bowing of the spine, osteoarthritis, and arthrosis. So these are the signs and symptoms of the acromegaly. So acromegaly, what's the difference between acromegaly and gigantism? Gigantism occurs during the childhood days, and acromegaly occurs between 20 to 40 years. Next, we are moving to the next hormone, prolactin. Prolactin. So mainly, this prolactin hormones it helps in the initiation and maintenance of the lactation, and it induces the ductal growth and the lobular alveolar system. So it takes parts in the especially takes parts in the synthesis of the milk protein like casein and lactoalbumin, and it helps in the control of the osmolality. Okay, so it helps in the metabolism of the subcutaneous fat, carbohydrate, calcium, and vitamin D, and it helps in the fetal lung development, and it takes part in the formation of steroid hormones from the adrenal cortex, testes, and ovary. So the overall effect of this prolactin mainly helps in the initiation and maintenance of lactation, and ductal growth and lobular alveolar system. That induces the ductal growth and lobular alveolar system, and it takes part in the synthesis of the casein and lactoalbumin, which is a protein present in the these two are known as the casein, and lactoalbumin is known as milk protein, and this prolactin helps in the synthesis of the synthesis of this milk protein, and it mainly helps in the control of the osmolality of the blood, and it helps in the metabolism of subcutaneous fat, carbohydrate, calcium, and vitamin D, and it helps in the fetal lung development, and it takes part in the formation of the steroids from the adrenal cortex, testis, and ovary. And next, coming to the see another section is the glycoprotein hormones. So these glycoprotein hormones are nothing but hormones which are released from the anterior pituitary gland. So first one is the growth hormone prolactin. So second one is the glycoprotein hormones. So these glycoprotein hormones are nothing but thyroid stimulating hormone, luteinizing hormone, follicular stimulating hormone, and human chorionic gonadotrophic hormones. So these glycoprotein hormones are made up of the two subunits, alpha subunits and beta subunits. Alpha subunit is common to the all the hormones. So, but there is a variation in the beta subunit. Let's see the closely observe the pictures TSH, LHH, CG, and FSH. So there won't be any difference in the alpha subunit, but there is a structural difference in the beta subunit. See this one. So there won't be any. You won't see alpha subunits are same in case of thyroid stimulating hormone, luteinizing hormone, follicular stimulating hormone. But there is a variation you can see in the beta subunits. Now, first let's talk about thyroid stimulating hormone. Thyroid stimulating hormone. So that thyroid stimulating hormone. So its molecular weight is 28,000, and it is secreted by the anterior pituitary gland. And the main important function of this thyroid stimulating hormone, the name itself indicates, stimulates the release of the thyroid hormone, that is T3 and T4 by the thyroid gland. So now, see the another name for thyroid stimulating hormone is the thyrotropin. Okay, so hypothalamus, as all of you know that the hypothalamus releases the thyrotropin releasing hormone, and thyrotropin
నేను ఒక్కడే
thyroid
ఎక్కడున్నావు?
So hypothalamus helps in the hypothalamic releasing hormones, facilitates release of the, it acts on the thyroid gland, facilitates releasing of the thyroid stimulating hormone from the anterior pituitary gland, and this thyroid hormone acts on the thyroid gland, and again it stimulates release of the T3 and T4 hormones from the thyroid gland, and it increases the metabolism, and growth and development, increase the catecholamine effect. So main important purpose of this thyroid stimulating hormone, so it converts the iodide to iodine. Okay, so iodide to iodine, because as all of you know that this iodine is essential for the, it binds with the tyrosine and forms the monoiodotyrosine, diiodotyrosine, tetraiodotyrosine, like this. See, for the conversion of the iodide to the iodine, this thyroid stimulating hormone is essential. And this thyroid hormone, what are the functions of this thyroid stimulating hormone? So it has role in growth, it has role in development, it stimulates heart rate, it stimulates heart contraction, and it stimulates the synthesis of protein and carbohydrate, and degrade the cholesterol and triglyceride, enhances the beta adrenergic receptor to catecholamine, and it increases the vitamin requirements. So thyroid stimulating hormone, we'll see in detail later in coming classes, the thyroid stimulating hormone. So mainly the thyroid stimulating hormone helps in the release of the, helps in the growth. It has a role in the development, and it stimulates heart rate, it stimulates the heart contractions, it stimulates synthesis of protein and carbohydrate, and degrades the cholesterol triglyceride, enhances the beta adrenergic receptors to catecholamines, and it increases the vitamin requirements. So next, gonadotropic hormones. So gonadotropic hormones are nothing but luteinizing hormone and follicle-stimulating hormone. So this luteinizing hormone and follicle-stimulating hormone, these two are the glycoprotein hormones. Okay, so see this one, the follicle-stimulating hormone, luteinizing hormone, this acts on the testis and ovary. Okay, so this follicle-stimulating hormone and luteinizing hormones acts on the follicle-stimulating hormone, acts on the testis and ovary, and it facilitates the release of the testosterone, sperm from the testis, and the ova, estrogen, progesterone from the ovary. At the same time, luteinizing hormone, it acts on both testis as well as in the ovary. Okay, so in males, it facilitates release of the testosterone stem, and in the females, it helps release of the ovary, progesterone, estrogen, and ova from the ova. So these are the role played by the follicle-stimulating hormone, luteinizing hormone in the body. Let's see the. Let will focus on the follicular stimulating hormone. So this follicular stimulating hormone. So for the release of this follicular stimulating hormone, luteinizing hormone from the posterior pituitary gland, from the anterior pituitary gland. So as all of you aware that the release of this hormones from the pituitary gland, that is especially from the anterior pituitary gland, so it has to be, it is under the control of the hypothalamus. So the hypothalamus releases the gonadotrophic release hormone. So this gonadotrophic releasing hormone key role in the reproductive function. So this gonadotrophic releasing hormone acts on the anterior pituitary gland, and anterior pituitary gland facilitates the release of anterior pituitary gland under the control of the gonadotrophic releasing hormone. Facilitates the release of the follicular stimulating hormone, luteinizing hormone. So this follicular stimulating hormone, luteinizing hormone, acts functions in the normal ovarian function and spermatogenesis. Okay. See this one. See this one. See the positive feedback control. So hypothalamus releases the gonadotrophic releasing hormone. Gonadotrophic releasing hormone acts on the anterior pituitary gland, and the anterior pituitary gland facilitates release of the FSH and LH. This acts on the ovary and estrogen progesterone. So when the sufficient amount of this estrogen progesterone release, and this inhibits the release of the via the negative feedback inhibition, it inhibits the anterior pituitary and hypothalamus. So follicular stimulating hormone. So this follicular stimulating hormone, say, so let us see the follicular stimulating, anti-follicular stimulating hormone, say glycoproteinase hormone, and needed for the development of ovaries and testes, and important for maturation of sperm, and it controls the menstruation and stimulates the follicle formation in the ovary, and stimulates the follicle formation in the ovary. That is role played by the follicular stimulating hormone. So follicular stimulating hormone, it's a glycoprotein. So it's needed for the development of ovaries and testes and important for maturation of sperm, and it controls the menstruation and stimulates the follicular formation. Let's see the role of luteinizing hormone. Luteinizing hormone is again, this luteinizing hormone is secreted by the anterior pituitary gland. This luteinizing hormone, the release of this luteinizing hormone again under the control of the gonadotrophic hormone. So this luteinizing hormone, as usual, normal ovarian function and helps in this release of the estradiol, and in males spermatogenesis and facilitates release of the testosterone. And luteinizing hormone promotes the secretion of estrogen from the follicles and releases the ovum from the ovarian follicles. And corpus luteum produces the progesterone, and estradiol produces the testosterone from the lytic cells of testes. So this is the role played by the luteinizing hormone. And next one is the very interesting hormone, that is the human chorionic gonadotrophic hormone. So the another name is the pregnancy hormone. Human chorionic gonadotropin. Human chorionic gonadotropin. So this hormone, the HCG, is produced by cells that form the placenta. That is nothing but syncytotropoblasts. Syncytotropoblasts. And this is the mainly this beta HCG, the indication beta HCG, once this lady conceives, this HCG hormone released into the urine. So testing of the HCG in the urine. So it's a simple, very simple pregnancy test. You just early morning fresh urine sample is essential for testing this for confirmation of the pregnancy. Simple one drop is essential because you know that the early morning urine contains the high concentration of the HCG hormone. So this HCG hormone stimulates the corpus luteum. Okay, and at the same time it releases the progesterone. So this progesterone prevents the menses and it supports the pregnancy. That is role played with HCG is the prevents the menses and it supports the pregnancy. So next, coming to the last hormone. So one you have seen the three sets of hormones are released from the anterior pituitary gland. One is the growth hormone prolactin. Next one is the luteinizing hormone, follicular stimulating hormone, and HCG and thyroid stimulating hormone. These are all glycoprotein hormones. Next one is the pro-opiomelanocortin. So pro-opiomelanocortin are nothing but beta melanocytic stimulating hormone, alpha melanocytic stimulating hormone, and gamma lipotropin, beta endorphins, and beta melanocytic stimulating hormone. These are all hormones. These are all known as the endorphins. So endorphins nothing but this is nothing but the happy hormones. So the happy hormones are nothing but enkephalines. Okay, adrenocorticotropic hormone, enkephalines, adrenocorticotropic hormone. So this adrenocorticotropic hormone and this pro alpha melanotropic hormones, these are all released from the how these hormones are released. So for the release of these are hormones are released from the anterior lobe, and the pro opiomelanocortin is a hormone released from the anterior pituitary. So these hormones are processed to small peptide hormone, that is the pro anticorticotropic hormone. From this pro anticorticotropic hormones, pro alpha melanotrophins and adrenocorticotropic hormones synthesis take place, and these adrenocorticotropic hormones are released from the for the release of these adrenocorticotropic hormones is again works under control of the hypothalamus. Hypothalamus releases the corticotropic releasing hormone. This corticotropic releasing hormones acts on the adrenocorticotropic hormone. These adrenocorticotropic hormones are acts on the adrenal cortex, and it facilitates release of the corticosteroids from the adrenal cortex. And this adenocorticotrophic hormones acts to the stimulation of cell surface adenocorticotrophic receptors, and this results in the stimulates the growth of the cells, adrenal cortex, and secretion of the gluco and melanocorticoids, and alpha and beta melanotrophins, and beta lipotropins, and adenocorticotrophins. So all these hormones are released from the so excessive secretion of these hormones leads to the Cushing syndrome. In Cushing syndrome, increase the blood glucose level and CNS irritability and personality changes and moon phase. Okay, and increases susceptibility to infection and gynecomastia and fat deposition on face and back of the shoulders, occurs osteoporosis and purple striae, thin skin, bruises and petechiae, and females amenorrhea, hysterism, and increased acidity, thin extremities, and fluid retention takes place. These are all symptoms of the excessive production of these hormones. So these are Cushing symptoms. Next, come to the example, another example, peptide neurotransmitters. Peptide neurotransmitters. So peptide neurotransmitters are nothing but dopamine, serotonin, endorphins, oxytocin. These are all known as the uh, these are all known as the peptide neurotransmitters. It helps happy brain. These are all happy brain chemicals. Enkephalines. Okay, so enkephalines. So there are different type of endorphins are there. Okay, human body produces at least 20 different types of endorphins. So these endorphins, alpha endorphins, beta endorphins, and gamma endorphins, and sigma endorphins. Among these, beta endorphin is a most powerful, and endorphin especially it boosts your immune system and produces euphoria and release from the brain. So this endorphins is nothing but endogenous morphine. It's just like morphine is a drug. Okay, it's a endorphin is a endogenous morphine, and this beta endorphin is the best brain relief, and so high concentration of the endorphin in the brain produces sense of euphoria, just like drugs. It's a natural drug which is present in our body, that is the endorphin, and it surpasses the brain and both emotionally, physically pains, and low concentration endorphin in the brain. People feel anxious, and they are also more aware of pain. Endorphin production is hereditary, and due to this, its production level varies from person to person. So endorphins are varies from person to person. So these endorphins are nothing but it's just like opium. Opium means ganza. Ganza in Telugu is called ganza. So in acupuncture therapy, especially these endorphins are released. So it relieves the pain. And melanocyte stimulating hormones, melanocyte stimulating hormone. This is a origin for this is pro-opiomelanocortin. From this pro-opiomelanocortin, alpha melanocyte stimulating hormone, adenocorticotrophine, beta lipotropin. From this beta lipoprotein, alpha tryptophan, beta endorphins, and from this beta melanocyte stimulating hormone takes place. And overall, for this bias of the endorphins, pro-opiomelanocortin is the starting enzyme. So melanocytic stimulating hormones secreted by the corticotrophic cells and release the hormone from the hypothalamus, increase release from the anterior pituitary gland. Function is not certain in humans, and it especially in frogs increase the skin pigmentation. Okay, so these are the hormones released from the anterior pituitary gland.
This conference will now be recorded.
Sir, attendance मतलब report ले.